So the definition of a derivative is written in terms of limits. F prime of x, so the derivative of some function, is the difference of that function and some arbitrary horizontal shift divided by whatever that shift was. And then we just let that limit, we let that shift shrink down to 0. So it's important to recognize this structure wherever you see it. If you're given a function evaluated at x plus h minus some function divided by h, then you know you're dealing with a derivative. Let's look at an example. So here, instead of the generic f of x, we're using tangent evaluated at pi fourths. As you know from trig, we usually use fractions of pi when evaluating trig functions. And at some point, you're going to learn that the derivative of tangent is secant squared. So let's have a look. The exact same structure here. Instead of f of x plus some arbitrary change in h, we've got tangent of pi fourths plus some arbitrary change in h minus tangent evaluated at pi fourths. And then if we were to shrink that down to 0, we could get a value, but we would run into the problem of dividing by 0. So we're going to go with the definition. Remember, this expression here, this equation, this is the definition of a derivative. So if you see this expression right here, you're being given the definition of the derivative of the tangent function at pi fourths. What is the derivative of the tangent function? Secant squared. So by understanding the definition of derivative, knowing some basic trig, and having remembered some of the more formulaic derivatives, that secant squared is a derivative of tangent, this limit can be rewritten as this function. Evaluating our expression in the calculator, the value of our derivative at pi fourths, which is defined as the limit as h goes to 0, is 2.